Right, this is just a small video for Crestron guys basically, and interfacing into the Niagara. We've got a BACnet network here, and we've got a Crestron. So I'm reading these points from the Crestron, and they're giving me the set point, the occupancy, and the fan speed that they want for each individual area. And then I take them points and use them. So let's just views wire sheet, and we'll look at the points coming out and where they're going to in my logic when it responds. Come on. So that's the drawing room space. So yeah, so these are points here, the Crestron points. I'm writing to the space temperature, and I'm reading the fan speed from Crestron, the occupancy, and the cinema set point, and that's the point that I'm writing to the Crestron value that they've given me, and that's coming from their Crestron room temperature. And then I also, in BACnet and export table, I give them different values so they can see what the underfloor status is, what the room temperatures are, the Crestron, the fan speeds of the AE200s, the temperatures, and whether it's healthy or not. So I've put them in my export table under my back network. And if we look at the back network, we'll be able to see the AE200, the Mitsubishi AE200, and the Crestron. Don't want links. BACnet device manager. Okay, thank you. So that's my AE200, that's my Crestron device on that IP address, internal IP address. So the points are created on the Crestron, and then I will take information, and I can also write to them points. And of course that's my logic. So the Crestron's just the front end for the client. All the work is done within the Niagara, and so the client doesn't see any of this logic or any of the graphics involved in here. The graphics that I just wrote for this are just simple graphics, just so I can easily see what's going on. It's taking some time to run up this logic. I know there's quite a few rooms there, but it still took some time to run up this logic. I think I'll just pause you. So there's the logic. I've got different folders for the different rooms. So that's my underfloor system. That's my Fanco systems, which has got underfloor built in there. And I'm just doing some calculation of the temperatures, minimum, maximum, and average. Selecting what mode. So we're working in outside air temperature, and we could work in demand. Now we've only got one outdoor unit, so we can either all do heating or we can all do cooling. We can't do both. Currently there's 4 units want cooling, 4 units want heating in the rooms, so it's half and half at the moment. So it'd probably be better to work on outside air temperature in this scenario. And if I look at the graphic, which is just a graphic for me, it's not for the client, you can see that the outside air temperature is 10.1. So they've asked for the fan coast to be on heat if outside air goes below 4 degrees, and to do cooling if outside air goes above 17 degrees. So at the moment the fan coil units are off, regardless of heating and cooling. But we've got some underfloor temperatures on here in red, and that's because the set point is 22 there and it's only 20, and 24 there and it's only 23.4 there, so hence that's why they're eating. So all this here on this left hand side of the Crestron points coming into me that I'm reading, and then I'm using that information like the set point and using that for my control, and then I'm sending back to them the Crestron side, I'm sending back to them the space temperature because they don't know whether what the temperature is, and I'm sending that back to them. And then we've got a Camstruck heat meter there, which I'm just taking some Modbus information from, and done a bit of logic there just for taking what kilowatt hours have been used in a day. I can show you that logic. I actually wrote it in the Camstruck heat meter page. Views, wire sheet, and I wrote it in there. So all I'm doing is taking a snapshot at midnight, before midnight, through this here, this numeric latch, so I'm latching that, and then I'm taking another snapshot after midnight. But before so I'm taking the first snapshot, then I'm resetting, this midnight one is actually resetting everything, and then, so that was what was used yesterday, and then I take another snapshot after midnight. So what will happen midnight tonight, or just before midnight, this will fire, which will give me the value of what we've used in kilowatt hours. Sorry, from there, this 0 kilowatts, will give me the value there. I then take a snapshot of that value to put it into there. I've got a history attached to that, and then I will reset it. So again, I'll have another 24 hours before we go to the next snapshot. So it's simple enough logic, but it works quite well. So he's taken the current heat meter kilowatt hours into there, and then that's the after one, which that's fired by this one here. But before we fire that, we fire the midnight one, which takes one away from the other. So that registers it, that takes a one away from the other and stores it in there, and this one after midnight starts it going again. So that's that bit of logic. Right, I think that's it. So that gives you a bit of idea of the Crestron and how we are talking or communicating to and from the Crestron. Crestron provide the points. I will provide the points for Crestron via the export table. So the points are all in there, but it's a little bit difficult with Crestron, so it's better that Crestron give the points. And by all means, you can read as much information as you want from there if you want to use it, if you want to read the information. But for adjusting set points, Crestron really needs to give the point. I can give them the point, but it's the way the Crestron works. It works better that we actually have the physical point that I can read from Crestron. Okay, thanks for watching.